Welcome back. What's going on? Today we're doing another Snort challenge. The challenge name is the basics. So in this room or in this video, the description is we will put your Snort skills into practice and write Snort rules to analyze live capture network traffic. We did something similar in the past, if you remember, where we actually investigated brute force and reversal attacks. The room name was live attacks. Live attacks is more advanced than the basics, and if you haven't worked with Snort before, I do not recommend you watching this video, neither this one. I recommend you to watch my video on Snort IDS IPS complete practical guide. In this video I went over the basics of Snort, how to write rules, configurations, and how to test them out on live capture. You can also watch my various videos on Snort IDS. I'm gonna put all of these in a playlist where you can navigate them easily. So in today's video, let's close these. Okay, so in today's video we're going to do the basics, where we're gonna solve various tasks, but it's gonna be very long to solve them all at once, so I'm gonna divide the video or split the video into multiple ones. In this video we're going to write rules for HTTP and hopefully FTP. It's worth to note that, guys, I suspect that some of the answers or some of the questions are not put correctly, especially the answer. So basically here, for example, in this task here, the first thing you are required to do is to find out the number of packets, detected packets. Now if you supply wrong number, you won't be able to answer the rest of the questions correctly, because the rest of the questions are heavily related to the first one and reliant on the first one. Okay, so if your answer here was incorrect, it means you won't be able to answer these questions correctly, because it means that your analysis was wrong. But surprisingly, whatever I put here is wrong, but my answers afterwards were correct, which means I suspect that the question here is kinda needs to be rephrased and the answer needs to be revisited. So nevertheless, let's now write IDS rules to investigate HTTP traffic. So basically, using the given pcap file, let me show you the machine here. So exercise files. So for every task we have exercise files. The machine is slow, I guess. Anyway, so we have task 2, 3, 4, and for every task we have exercise files. Now for every task we have a given pcap file, a packet capture file, and a correspondent Snort rules file. Okay, let's go now to task 2. Hopefully the machine will respond. Okay, now it's fine. All right. So cd, let me make this bigger so people won't complain about the font every time. I recommend you guys to watch the video in full screen if you are watching this on mobile devices. So now cd desktop, cd exercise files, and now we're going to start with task 2, HTTP 2. Okay, so here we're given a pcap file and local rules. Now there's no Wireshark on the machine, and the objective here is not to analyze the file with Wireshark. The objective here is to analyze the file with Snort and extract statistics about the numbers of packets, TCP packets, so on and so forth. Okay, write rules to detect all TCP port 80 traffic packets in the given pcap file. After we write the rule, we require to find out what's the number of detected packets. Detected packets are the packets where an alert has been generated, or the packets that have triggered alerts. So basically in Snort, we have to find out the number that corresponds to the field alerted, or number of alerts. Number of alerts correspond to the number of detected packets. So there are two ways to answer this question, guys. The first one is to write the rules first and then analyze the file, find out the number of alerts, or we analyze the file, okay, and using Snort packet logger mode, we will be able to filter for HTTP traffic. Two ways to answer the question, but the intended way actually is to write the rules here. So let's write rules to detect HTTP traffic. Sudo nano local rules. Okay, since we're talking about alerting, we're going to use the word alert. Protocol is TCP. Okay, so detecting HTTP traffic can be inbound or outbound. The objective here is to find out the number of HTTP packets, inbound and outbound. So outbound could be any, and then destination will be any, port 80. And here I'm gonna borrow some lines to write out the other fields. So let's take this one, and here change on, yeah, this one HTTP packet found. This one is fine. Okay, now alert TCP. Now we were talking about inbound traffic. This is outbound traffic coming from your network to any server on the internet on port 80. Now what if the server responds back to us by displaying the page we requested in the browser? It's going to be any and port 80, and then the direction will be to my network, any. Again, we're going to copy that. Change these, revision 2 and SID, change the SID as well. These numbers need to be unique for every packet, for every rule. Now we have two rules. We're gonna close this file. So now we are ready to start analyzing the PCAF file. Now there are two ways to find the number of HTTP packets, as I told you in the very first. We can either analyze the PCAF file using Snort, or we can analyze the file but after we write the rules. Let's first go the first path. Sudo snort -c local rules. Okay, we define the rules that we will use, and then we define -rd packet capture file m. Okay, in this mode, if we run this command, we will be able to detect statistics about the PCAF file without any logs generated. We would like to generate logs, so we're going to type -dev -l dot. This will start Snort in packet logger mode and log everything in the current working directory. So enter. Okay, so we have generated, or we have analyzed around 460 packets, and the action was allow, as you can see. Now, out of which we have 164 alerts. So the number of detected packets is 164. ls, as you can see, we have generated one log file and one alert file. If you view the alert file, you will see all of the alerts that have been generated as a result of the rules that we have written on the rules file. Let's take a look at the alerts. So as you can see, all of the alerts are equipped with the message, or are showing HTTP packet found as a message, because this is the message we have written on the rules file. And we can see here the source IP, source port, destination IP, and destination port. All of the packets, if you look at them, they have port 80 in them. Port 80 all the time in different directions. So this is the alerts file. Now this is the log file. To analyze the log file, we will have to use Snort. Sort dash r, and define the name of the log file would be like that. And then if we want to analyze specific number of packets or certain packet number, we would have to use -n and specify the number of packets we would like to display. So in TryHackMe questions here, I suspect that there is something wrong with the questions. Some questions I was able to answer correctly and some of them I couldn't. And the thing is that if you have run your analysis incorrectly, you shouldn't be able to get any of the answers correct. Okay, but weird enough, I was able to get some of them correct and some of them not correct. So I would suspect that there is something wrong with the questions. Although guys, I recommend you to go over the room, and if you were able to figure it out, just correct me in the description of the video if I was wrong. Okay, so the questions here require you guys to find out the number of detected packets, meaning the number of alerts, and extract certain information from certain packets. Namely, you will have to extract information from packet number 63, 64, 62, and 65. Now, to extract information from a certain packet number, we would have to look at the packet number. For example, in this question, what is the source IP address of packet 65? Okay, the same way with this one, 63. So ideally, we would analyze the log file and here display the number of packets. Since we are trying to analyze the packet number 65, we're going to display here 65 packets literally, and look at the last packet. So enter. Cannot additionalize bcap, permission denied. Okay, I'm gonna have to append this with sudo. Okay, so as you can see, we have extracted 65 packets. If we take a look now at the last packet, the last one, which happens to be the packet number 65. The question is saying or asking, what's the source IP address? If you take a look at the packet, as you can see, from the direction, you can figure out the source. The direction is like that, left to right, which means this is the source and this is destination. So this is the source IP and this is the source port. As you can see, like that, you can answer the questions this way. And likewise, guys, you can answer the rest of the questions. Instead of 65, write 64 and 62 in the command here. Okay, let me move now to writing rules for detecting FTP traffic. Okay, so this happens to be task number 2. So we're going to move out here to this directory and ls cd to task number 3. Okay, again we have 2. Pcap file and local rules file. Let's now open the local rules file. I'm going to open, since this is a room for the basics, I'm not going to do it in the nano, I'm going to do it in the regular text editor. So here we're trying to detect FTP traffic. So first we would use alert keyword TCP. The first direction will be outbound, source any, destination port. This is the direction. Destination could be any, the web server, the FTP server, and the port will be 21. Now again, let me borrow this one. The rest of the rule details, revision number 1, no problem. And here instead of hey HTTP, I'm going to type FTP. Okay, and now the next rule will be for the inbound direction. So inbound meaning that the FTP server is sending a response to me. So which means the source will be any, the source port will be 21, the web server, the FTP server port, and I am the destination and the port will be any. Okay, change the revision number to 2 and SID into 2, and there you go. So we finished now from the rules file. Let's go back and start the analysis. So sudo snort -c local rules -dev -l. Okay, FTP. Okay, so what is wrong? Let's see here. Cannot set. We have -r here. Okay, So in total we have detected 421 packets, out of which we have 307 alerts, which means 307 is the number of detected packets. Again, it didn't work here. If I type this, it won't work. Let me correlate the results with another way of finding out the FTP traffic. You don't need now, actually you don't need to run Snort in packet logger mode to find out the number of FTP traffic, FTP packets. You can just analyze the PCAF file alone. So if you type snort sudo snort -r FTP, and here we filter for port 21. As you can see, again we got the same number, 307. This correlates the answer or the results we got from the first by running Snort using packet logger mode. So now let's see, what is the FTP service name? Now we're gonna have to look at the alerts file to find out details about the FTP packets. Let's click on the alerts. Let's see here. So this is the source IP, and this is the destination IP address on port 21. And here we have a response from the FTP server to this address. Combination of request and response FTP packets. Okay, so what is the FTP service name? So to find out the service name, we have two methods. We can analyze the log file, or we can analyze the PCAF file. The objective here is to analyze the log file. So let's now type a command to extract the service name, sudo snort -r, the log file name, and let's filter for the FTP traffic, or let's type -d first. -d is extracting packets in full packet or in full data dump mode, which enable us to find out or to find the details of the packet. Okay, -d, and then we filter for TCP port 21, TCP and port 21, and then display only 10 packets. Why 10 packets? Because we would like actually to find out the first 10 packets when the connection has been initiated. This will show us actually the FTP service name -n10. Okay, let's scroll up and find out. So this is the first packet, next packet, third, fourth. As you can see, Microsoft FTP service. So this is the service name, Microsoft FTP service. Okay, clear the previous log and alarm files, deactivate, comment all rules, write a rule to detect failed FTP login attempts in the given PCAF file. Okay, great. Now let's remove the log files, the sudo rm snort, and we will remove the alerts. Okay, let's now. Okay, so let's comment out these. Now I want to alert on failed login attempts or FTP login attempts. So what we're gonna have to do here, we're gonna type a rule alert TCP any to, or in both directions. Okay, any. We don't care now about the port. We care about the content of the packet. So we're gonna use these as an example. Just initially, I'm gonna correct them. Use this one, and here place 2 with 1. Now the message will be failed FTP login attempt, failed FTP login found. Okay, and then we have to use the keyword content and specify the content we are trying to filter. So here the content will be plain text detected in the packet details. When someone fails or initiates a failed login attempt, the packet will contain specific plain text data. In this case, it's given in the hint, as you can see. It's telling you that each failed login attempt prompts a default message with the pattern 530 user. So if you take this one and use it as a filter, okay, now let's see here. Okay, so what's the question here? What's the number of detected packets? Detected failed login attempts. That's why here we didn't specify a port. We would like to find out all the packets where the content is 530 user. Okay, let's now try this out. Sudo snort -c local rules -dev-l, and then we specify the, nope, I forgot the -r FTP, and this is the pcap file. So what do we have? Bad data. What did we miss? Yes, the semicolon. So it is the semicolon. Hopefully I will get the correct number of packets this time. So we have 41. Is this correct? And it is correct. We have 41 packets. As you can see, we are able to find answer the questions correctly, but the first one, nope. And it's giving us a warning that if you don't answer this question correctly, you won't be able to get the rest correctly. Okay, no problem. The next one, to find out the successful FTP logins. So in this time, we're gonna have to revisit the local rules file, and we're gonna have to change on the content here. So it's given again as a hint. The packets or the successful login attempts will have 230 user as content in the packet details. So we're gonna replace this here with the new criteria, and we will be able to find out the successful logins. Let's remove the old log files. Sudo rm snort and alert. Okay, sudo snort -c local rules -dev-l and -r. There you go. How many packets we have? 1. It's supposed to be 1 actually, right? Successful logins happen only once. Okay, next one. Deactivate, etc. Write a rule to detect failed login attempts with a valid username but a bad password or no password. This one is a bit more specific. Again, it's given in the hint. Let's take a look. Each login attempt with a valid username and bad password prompts a default message with the pattern 331 password. This means that your password is incorrect, but your username is correct. You get the idea now. You have to filter using the content. So again, nano, we open the rules file and we change on the content here. Remove the old log file and the alert file and run snort again. So we have 42 packets with correct username and bad password. Let's see. Correct. The last one, write rule to detect failed FTP login attempts with administrator username but a bad password or no password. Hint, you can use the content filter more than 1 time. So here the content filter will be used twice. The first one to filter for packets where the packet contains the word administrator, and the next filter will actually be the same as the old one, or the same as from the previous question, which is 331 password. Okay, let's do that. Again, let's remove first rm, the old log file, the old alert file, nano local rules. Keep this as is, and we write here another one. So content 331 password, again content administrator. Let's see if this works. Run, and we have 7 packets. 7. and that was the correct answer. So that was for today, guys. I hope you liked that, and we will see you in the next video.